Today the FRQs came out from the 2023 AP Stat exam, and I'm going to try to work these cold and put together my solutions and post them on the internet and see how it goes. Question number 1, part of a study on the chemistry of Alaskan streams. Researchers took water samples from many streams with temperatures colder than 8 degrees Celsius and from many streams with temperatures warmer than 8 degrees Celsius. For each sample, the researchers measured the dissolved oxygen concentration in milligrams per liter. Researchers constructed the histogram shown for the dissolved concentration in streams from the sample with water temperatures colder than 8 degrees Celsius. Based on the histogram, describe the distribution of dissolved oxygen concentration in streams with water temperatures colder than 8 degrees. So this display is for temperatures colder. We're not told how many, so we need to describe the distribution. We've been told before that's to cuss and BS. So the first thing we need to know is how to describe the center, the shape. The shape's pretty easy on this one, the spread, and any unusual features. So I'm going to look for the center, and we're going to use the median because we can easily calculate that by writing. I'm going to put here, I'll move this. So that I can show you how we're going to calculate this. Part A, on number 1, we're going to go 1 plus 1 plus 1 plus 13 plus 12 plus 15 plus 40 plus 94 plus 117 plus 89 plus 46. So I don't make any errors trying to add it in my head. I'm going to take the first 3 ones plus 13 plus 12 plus 15 plus 40 plus 94 plus 117 plus 89 plus 46. That's 429. That's the sample size. I'm going to divide that by 2. The 215th element. So if we count up 215, this is going to go 3 and 25 is 28, plus 15 is 43, 83, plus I'm going to do 100 minus 6 would be 183 minus 6 would put me at 177. And so add 117 to that. That's going to put the 215th element in the 11 range. So I'm going to say that the median of the distribution I'm going to use context here, of dissolved oxygen concentration in streams with water temperatures colder, it's going to put less than 8 degrees Celsius, is 11, and this is going to be milligrams per liter. And that takes care of the center. We'll get to unusual features in a minute. I'm going to go ahead and do the shape because that's easy. The distribution. Is left skewed. The spread, I'm going to look for the interquartile range here. And since we have basically, if we look at this distribution, we've got the 215th element here, we've got 214 elements here, 214 elements here. So half of that is going to be 107 and 107. So the 108th element and the 109th element will go together to make Q1. So I'm going to count up again, and I'm going to get 1, 3, 28, 43, 83. I'm looking for the 107th. That's going to be in the 10. So Q1 is equal to 10. And Q3 is going to be 107 from 107 and 108 going backwards from the last elements. So this will be Q3. I'm going to count back, and that's going to be in the 12. It's going to be 12. So for that, the spread, I'm going to say the IQR of the distribution I'll go ahead and show how we calculate it here. Equals Q3 minus Q1. We want to communicate that we know what we're doing, not just that we can guess lucky. Is 2 milligrams per liter. And now for the unusual features. I'm going to guess that we have some outliers here on the low end of this range, because outliers will be less than Q1 minus 1.5 times IQR, which equals 10 minus 1.5 times 2 is 3. And so that's going to be 7. So outliers are less than 7 or more than, and this will be Q3 plus 1.5 times IQR, and that's going to equal 12 plus 3, or 15. We have no outliers on the top end. We do have outliers. There are 16 outliers. Measuring 2, 4, 5, and 13. We'll put one each here to communicate that, since it's done it. 13 measuring 6 milligrams per liter of dissolved oxygen. And that should take care of part A. So we'll go to part B. The researchers computed the summary statistics shown in the table for the dissolved oxygen concentration in streams from the sample with water temperatures warmer than 8 degrees Celsius. This is not the same sample. So in this case, they gave us the min, Q1, median, Q3, and max. We all know that part to be the 5-number summary. And then they give us the mean and the standard deviation. So we want to use the summary statistics to construct a box plot for the dissolved oxygen concentration in streams with water temperatures warmer than 8 degrees Celsius. Do not indicate outliers. Okay, so we're just making a straight box plot where I'm going to just go ahead and put it on my paper here. I'm going to make the minimum is going to be 2.1, and the maximum is going to be 13.5. It says the median is 5.3. So if this is 11, then half of that would be 5.5. So half of that would be about 2.7. So a little bit more than that. I'm going to put the median right here at 5.43. And Q1, 4.39. And Q3 at 6.12. So that's going to be a little bit less. That's not as to scale as I would like, but I think this will suffice since I'm not doing it, so I'm doing it on a blank sheet of paper. So we have the min, Q1, the median, Q3, and the maximum for a box plot. Would have tried to make it to scale if I was using their plot. Oh, they had the numbers on there for theirs, so that would have been a little easier. But I couldn't access the printer before I started this. It was busy. The researchers believe that streams with higher dissolved oxygen concentration are generally healthier for wildlife. Which streams are generally healthier for wildlife? Those with water temperature colder than 8 degrees Celsius, or those with water temperature warmer than 8 degrees Celsius? Using characteristics of the distribution of dissolved oxygen concentration for water temperatures colder than 8 degrees Celsius and characteristics of the distribution of dissolved oxygen concentration for temperatures warmer than 8 degrees Celsius, justify your answer. Okay, so here we have 75% of the data. Let's see. Higher dissolved oxygen concentration are generally warmer. Since the median, let's go Q3, is 12. Q3 is 6.12 in the warmer. And we're going to say 13.5. I'm going to argue that the median dissolved oxygen concentration in streams colder than 8 degrees Celsius is more than twice, the median in streams warmer than 8 degrees Celsius. Q3 in colder streams let's go Q1. Q1 in colder streams is almost 6 degrees higher than Q1 in colder streams, or in warmer streams. Let's do it like this. Let's say that Q1 in colder streams is almost 4 degrees higher than Q3 in warmer streams. Meaning 75%, more than 75%. Let's just say 75% or more of the colder streams have higher dissolved oxygen concentrations than 75% of warmer streams. I hope that's clear. I hope that's clear. I think that should be clear enough to describe that. Therefore, you need to answer the question. Don't forget to answer the question. Which streams are generally healthier for wildlife? Therefore, colder streams appear to be generally more healthy for wildlife. Is there a part D? Nope, that's the end of question 1. Let me know what you think if you see this